Let's talk about sections. I will enable that Boolean, compile and save, clear the log and hit play. Filter for section. We can see we've got a movie scene float section, a movie scene 3D transform section, a movie scene color section, and then a movie scene parameter section, and there may be some other ones sprinkled through here, but there's essentially a class dedicated for all of the different kinds of data that are contained by the section. And if we look at the parent class, which is going to be movie scene section, there's a decent amount of functionality. For the subclasses, movie scene float section, movie scene color section, and movie scene 3D transform section, it's essentially just some editor properties, and any functionality is inherited from that parent class movie scene section. One of the exceptions is going to be movie scene parameter section, which actually has a few additional things on them, including this method here, get parameter names. So if we can successfully cast our section object to a movie scene parameter section, we can call that get parameter names function. That's going to return a set which needs to be converted to an array, and then we can just iterate over that array using a for each loop, printing out parameter name. So let's take a look at what that looks like. Go ahead and clear the filter. So you can see we've got in the, we'll go up a little bit further actually. So in the first object, that's going to be the fog box. There's a material associated with that, material element 0. It has a movie scene parameter section, and the name of those parameters are going to be opacity, fog color 1, and fog color 2. And then for the SM pillar circle, has this, I guess I can probably hit stop there, has this material in there with the emissive. We see now the fire emissive is being printed as well. I'm not entirely sure why these guys are being printed. There may be a problem with my blueprint logic, but it seems like it should either print these or these based on what the bound actor is, but I don't know, maybe the stuff is being stored somewhere. Okay, let's take a look at the next area down here, which is going to be channels. And we can access the channels using get all channels, which is available on the movie scene section object directly. So we can pull off here, regardless of what kind of subclass it is, they will all have this get all channels function. Let's go ahead and click on the channels branch there. Compile, save. Go ahead and run it. We'll type channel here into the filter. And you can see we've got a movie scene scripting float channel. And I believe, that's because I'm filtering there. Let me just go ahead and pipe in like this. We'll run that again. Okay, this is what I was looking for. So we've got a movie scene scripting double channel and a movie scene scripting float channel. The only difference between a float and a double is a float is a 32-bit decimal point number and a double is a 64-bit decimal point number. And the reason that we are using different data types here is for the fog color, which is going to be a linear color between 0 and 1, 32 bits is enough data to effectively communicate that information. Whereas for something like location, where you might have a very large number, they want to use a double. If you look at the documentation for both of these classes, movie scene scripting float channel and movie scene scripting double channel, they have pretty much the same methods on them. If you look at the parent class though, there's very little there. So both movie scene scripting double channel and movie scene scripting float channel have a method called getKeys. So if we want to access the keys associated with this channel, we're going to have to cast it. We'll go ahead and stop that. So I have here the cast set up for the float channel, which should be happening already. So we're just going to cast it to a movie scene scripting float channel. We're going to use the getKeys function there, and then iterate over those keys, get the object name, get the class, and print that stuff out. So I believe I've probably already done that. I'm going to type a key in here. And we can see pretty much all of these are going to be a class called movie scene scripting actual float key. So let's check out the docs on that. So with the movie scene scripting actual float key, there are no associated methods or editor properties. If we go up to the parent object, we can see a lot more of that stuff. And what we'd be looking for here is a get value. If we look at the actual data type here, this is going to be a movie scene scripting key, which is actually the parent object of our movie scene scripting float key. There we are, movie scene scripting key. And if we look at that, alas, no functionality. So once again, we have to do a cast here. Now we could cast it to this, which would evaluate as true, or we can cast it to its parent object, which will also evaluate as true. So I think we'll go ahead and do this one. Just copy this, movie scene scripting float key. So we'll pull off. And plug this one in there like this. And then as a movie scene scripting float key, we now have access to the get value function, and we can just print that. We'll do a compile and a save. We'll clear the history, clear the filter, hit play. And now we're getting key values. So the key name is going to be blah, blah, blah. And the object it's associated with is going to be the post-process volume. So you can see here what those channel names are and what the values of the keys are as well. So let's see if we can put this together with what's actually going on in the sequence itself. So we have the skylight. This is going to be the skylight component 0. We have the channel name doesn't have, or there is no channel name, but this is going to be the intensity for the track name. And we have two key values, 5 and 13. So let's see if we can track that down. There's our skylight. There is our skylight component. Here is the intensity. We have two keys, and the value for the first key is 5, and the value for the second key is 13. So we are not passive observers here. We can modify this data as well. In addition to get value, there are some sets down here. So you can set the time and you can set the value. So let's just grab this. Come over here, type in set value. And I'll just take whatever this is and we'll just add 10 to it. It's a little bit out of order here. I'm not that worried about printing it anymore. Type in like this. Make sure we're actually adding something. We'll do a compile and a save. We hit play here. You can see there is suddenly a whole lot more light in here coming from our freshly invigorated skylight component 0, going from 15 now to 23. So there you go. Hopefully that has been a useful walkthrough of how to access at kind of a forensic level of detail every single thing that is present in your level sequence using the director blueprint. It's hopefully also a pretty good demonstration of the wild utility that is available here using the Unreal Python API documentation. And if you are curious to learn more about Python and Unreal, I have a course available for free through the Epic developer community called Utilizing Python for Editor Scripting in Unreal Engine. And it'll go through some of the basics and get you started with working with Python and Unreal. It's pretty useful. So please feel free to check this out as well.